Our topic is 3D printing, 3D bioprinting in biology. And our group members are Paul Limpin, Nisha Johnson, Abraham Constantino, and Marla Manzano. Okay, so we already have the capability to print in 3D currently, used to create models and prototypes along with many other uses. But did you know 3D printing existed in biology? Through our current 3D printing technology and after much research, we have today three-dimensional printing capability in biology. This technology is used for a number of different medical and tissue engineering fields. However, in order to understand why and how it's used, we must first take a look at what it is. So, what is 3D printing in biology? The concept is the same as a traditional 3D printer, except this printer uses bioink instead of the traditional ink to create body parts. Bioink consists of biomaterials, cells, and other growth factors. Where does it get the data to print? Well, the printer gets its data from a computer that uses a design software. It then takes that design and layer the bioink in a crisscross pattern to create the 3D image.
All right, history. The history of bioprinting. First idea of 3D printing appeared in 1980 when Hideo Kodama established the first patent. The technology grew fairly quick as soon as the patents expired. His patent described as a photopolymer rapid prototyping system which used UV light so that it could harden materials, but at the time it was just an idea. It was never commercialized. We would have to wait until his patent expired. A few years after, only a few companies developed the technology. It wasn't until 1984 when Chuck Hull built the first 3D printer. He was working for a company that was using UV lamps for fashion. That's when he got the idea to use ultraviolet to form his small 3D printer prototype. Later on, he filed his patent for his invention in 1984, then began rapid prototyping commercially. Then Thomas Bioink creates the first 3D bioprinter, which is capable of printing live tissue in 2003. This would lead to the first 3D blood vessels to be bioprinted in 2009. Also to our current bioprinting technology happening today, which vary from bioprinting human skin to actual 3D organ structures that help regenerate damaged tissue. And next slide.
So there are hundreds of companies that offer the same incentives in bioprinting and 3D printing. And one of those companies are right here in San Diego in Organovo. They have a very impressive resume over their competitors in medical research and drug discovery. And one of their highlights is in 2014 when they were able to successfully 3D print liver tissue that became a real functioning liver just a few weeks later as a test subject. And they followed that up a year later just by successfully 3D printing a human kidney with all those tissues generated. This was not a medical test, this was just the lab test. And with this line of successes that they had, they sought FDA approval in 2018. And after a year of research and development, they were granted special permission in 2019. And with that recognition, they landed partnerships with Yale and other prestigious universities to work with them and develop their research even further. Next slide, please. Why do we need bioink in 3D printing? Why is this significant? So we have to look at the daily usages of bioink and their incentives for it. So with bioprinting, we can look at ethic reasons. We can move away from animal trials and turn for synthetic, yet still accurate tests on artificial tissues and organs. Turning to a medical perspective, we can lessen the wait times for transplantations drastically. And patients don't have to look for a deceased organ donor who has the perfect match for them, as they can simply order an organ straight from the facility with what's called perfectly fitting their own needs. And with that too, patients can go home without fearing any setbacks in their surgeries. They can go home with their organs not without being rejected, and they can save on both fronts, on both costs and well-beings. They don't have to spend money on antibiotics, and they don't have to weaken their immune system because of it. And speaking of ethical, when we bioprint, we can also bioprint food. And with bioprinting food, there are no animals that are at the expense of our bioprinting. So it's a win-win for everybody. And who is going to benefit exactly from bioprinting? We would say it's medical, because when we look at medical professionals can use 3D printing to repair damaged ligaments and joints in a much shorter time and much lower costs, because they don't have to look for other resources to get their tissues and repair stuff, and they don't have to source those materials any other way. And with bioprinting being a now modern tool since 2007, it's a greater emphasis for medical professionals.
Okay, I will be presenting a short video so you guys can get an overview of what 3D bioprinting is. Play.
Aspect Biosystems is a Canadian biotechnology company building living 3D tissue solutions for the life science industry. Aspect's proprietary lab-on-a-printer platform is one of the most advanced tissue engineering technologies in the world, capable of rapidly 3D printing human cells with biological scaffolds to generate complex living tissues. Developing a useful 3D tissue begins with defining how the tissue should function, then conceptualizing how to construct the tissue to display the desired functions. Generating a biologically relevant 3D structure is essential to recreating lifelike function. Once the tissue structure is defined, the 3D bioprinting protocol is designed to enable the rapid and accurate fabrication of the living tissue. Aspect's unique lab-on-a-printer microfluidic technology enables switching between different cell types and scaffold components on the fly. The living fibers we generate are deposited layer by layer to rapidly and accurately build heterogeneous tissues with well-defined regions. In order to recreate biological function, the bioprinted structure has to be grown for several days in specialized culture conditions. During this maturation process, the printed cells form interconnected networks, resulting in a lifelike 3D tissue. The tissues we build have highly physiological functions. Here is a 3D bioring made of airway smooth muscle cells, contracting in response to histamine and relaxing in response to salbutamol, recreating an asthma attack in a dish. The highly skilled team of engineers and biologists at Aspect Biosystems are enabling the production of customized tissues on demand for disease research, regenerative medicine, and drug development. Aspect Biosystems, human tissues on demand. Contact us to learn more about accessing our unique bioprinting technology.
Okay, so some of the pros of 3D printer are freedom of design, which quote unquote often complex geometry cannot be made with traditional methods because some areas may be impossible to machine or be able to be removed from a mold. However, with 3D printing, the additive process and the use of support material make it possible to make any type of geometry. And also another pro of having a 3D printer is it's print on demand, so it avoids overstock and costly inventory, and it prints pretty quick. And another pro is lighter, stronger parts. And in 3D printing, you use plastic, which is way lighter than steel and aluminum, which moves all the parts way quicker. And the speed is much quicker, and it's better also for the environment. And there's a few cons to the 3D printer, which is limited materials. Primarily, 3D printing produces parts in a limited selection of plastics and varying mechanical properties. And the post-processing also. Most 3D parts typically need some type of cleanup in post-processing to remove support material and smooth the surface finish. This can include water jetting, sanding, and chemical soak and rinse, air or heat dry, assembly, and more. And this is one of the sources I used for the cons. And these are the rest of our sources as well.